Let us start today the key concepts in SEM. As we are aware of, SEM is rooted through theory. So let us understand what is theory, what theory contains, and what is the role of theory. A body of description of a knowledge is usually called a theory. Any theory should contain a set of principles or constructs, assumptions, boundaries, and limitation. A theory should be falsifiable at any moment. Normally, thesis deals with a theory, and theory can be tested or built. Now, the role of theory, which speaks more about describing, exploring, or explaining or predicting the phenomena in the given context. One of the key things with theory, a theory contains a construct. So, we should understand what is construct. A construct is abstract by nature. A researcher constructing the ideas based on literature review or his own experience. It is a medium to communicate the ideas among the domain scholar. A construct cannot directly measurable, but indirectly through dimensions or set of logical grouping of attributes. The next thing is, as we are aware of SEM, which is a combination of factor analysis and path analysis. In other words, a SEM is a combination of measurement model and a structural model. So, the first thing we should understand, there are two types of factor analysis in SEM. One is what we call as exploratory factor analysis, other one what we call as confirmatory factor analysis. EFA is a data driven statistical technique. It is used to explore the factors. The main purpose is to dimension reduction and summarization. But in terms of CFA, CFA is a theory driven, a statistical technique. The main purpose is to confirming underlying structure of the factors. And in EFA, we should aware of something called eigenvalue, which decides number of factors. A factor loading should be a minimum 0.5, and it is a cross loading by nature. So, rotation matrix help us for ease of interpretation. It is a technique used to develop a scale in a social science research. In terms of CFA, there is no cross loading. It is hypothesis oriented. It is to test how far observable or manifested variables can represent a latent. So, these two things are fundamental for or foundation for a SEM application. Next is we will see correlation and covariance in SEM. When you take most of the software, when they are using a EFA model, by default they use a correlation, and in terms of CFA and SEM, the default thing is covariance matrix. Now, the correlation is a statistical technique and used to establish a strength of relation between two variables. It is a standardized one, and the coefficient of correlation ranges between -1 to +1. In terms of covariance, there is no such standard like that, because it is fundamentally based on unstandardized one, and most of the software by default they will use a covariance matrix when they are using a CFA and a SEM model. Otherwise, there is no much difference between correlation and covariance. So, as we are aware of that, SEM is a blend of measurement model and path model. EFA, CFA, it is representing the measurement model, and path model is represented by using a mediator or moderator. When you see the mediating variable, it is an intermediate in the causal sequence relating an independent variable to a dependent variable. That is, independent variable causes a mediating variable, which then causes the dependent variable. That is what we call as mediating variable. Normally, when you say mediating variable, we are trying to assess the indirect effect between x and y. When you say moderating variable, it is a kind of qualitative variable, or it may be a quantitative variable also. It affects direction or strength of relation between an independent variable and a dependent variable. Now, this M, what we normally call in moderating effect, we are trying to assess the interaction effect. So, in a very short, if you come across mediator, the purpose of checking mediator is how and why things are happening in order to assess the indirect effect between a independent variable and dependent variable. When you say about moderating variable, it is more about interaction effect between independent variable and dependent variable. So by and large, SEM is a combination of confirmatory factor analysis and path analysis. It tests a theoretical models using a scientific method of hypothesis testing to advance our understanding of the complex relationship among the constructs. The goal of the SEM is to determine the extent to which the theoretical model is supported by the sample data. Extending the theory to the new arena of the domain is one of the key objectives of the SEM. When we are using SEM, it is very important to make SEM output more meaningful, because most of the people are reporting the SEM sometimes doesn't make any meaning at all. So to make our output, especially SEM output, more meaningful, let us follow some of the criteria. Number one is model specification is supported by relevant theory. We cannot make a model just pulling some independent variable, dependent variable, whichever the way we want. It has to be supported by a relevant theory or rooted through some of good literature work. And the second thing is, what are the measures we are using? It has to ensure the reliability, validity. So for that purpose, it is better to use a scale which is already attained high reliable and validity. And data quality is more important. And as we are aware of, most of times the SEM captures or SEM uses the questionnaire based data method. In questionnaire based data method, we have a lot of bias. One of the key bias, what we call a social disability bias. Respondent tendency has to over report positive and under report negative. So obviously that leads to some kind of bias. And using that kind of data for the SEM may not make more meaningful of the SEM output. And next thing is, as we are aware of that, SEM is in social science, most of time we dealt with the psychometric properties rather than physiological properties. In any psychological properties or psychometric properties, the measurement error is very much is feasible. One thing is, we cannot completely remove the error, but we have to follow something called permissible level of measurement error. For instance, dimension wise we can check Cronbach alpha, CR and AVE. Cronbach alpha and CR should be more than 0.7 and AV should be more than 0.5. And as we are aware of, SEM is more about, it's a relationship between the path. So we have to ensure that the relation between paths are statistically significant. And SEM contains a lot of good indexes and bad indexes. The good indexes such as GFI, CFI, TLI, goodness factor index, then confirm factor index, then Tucker-Lewis index. These all the things should be more than 0.95, and bad indexes such as RMR, SRMR, RMCA, this all should be a close to 0 or at least less than 0.05. And CMIN is a chi-square divided by degrees of freedom. It should be as close to 0, but anything below 5 or in the worst case anything below 7, it is most welcome for us. At the end of the day, whatever we are doing through SEM, it has to contribute to theory development or theory testing. So if all these points are ensured, obviously the output what we made through SEM makes more meaningful for us. For detailed guidelines, I request you to follow Hugh and Bentler guidelines, what to do, what not to do with a SEM application.